Could you start with sort of your path and not how you came to Atlanta today, but just your story, because it's so fascinating, and how you came to be doing what you're doing?
Yeah, of course. I mean, it's honestly been a lifelong passion for me at this point, right? But for me, I mean, I've lived at the intersection of AI and data centers for over a decade now, and it actually all began when I joined a much smaller Google back in 2010. When I think at the time the company was something around 10,000 people, and Joe Cava's organization was about 80 people globally. So
and Joe Cava was head of data centers at Google.
Yes, that's right. Even today, right? And as a side note, the very first Google data center, or very first data center I ever visited, period, was actually in Atlanta at Google's Lithia Springs facility, where they had like these like shipping containers of data centers, which at the time was our concept of like what a modern large data center is, right?
Yeah.
So I joined Google in 2010, and Google was small enough and nimble enough back then that even young college grads got a lot of responsibility. So I helped design and operate some of their very large mechanical cooling systems, right? Okay. And then I became the person within Google responsible for their PUE, their power usage effectiveness metrics, right? And every quarter, ORs who led technical infrastructure at the time would ask the same two questions, which were, what was our PUE last quarter, and what are we going to do to reduce the PUE further, right?
Can you pause for one second? Can you explain to people, you said what PUE stands for.
Yes.
But what's the goal? Where did it come from?
Totally.
Why was this important to them?
Totally. So PUE, power usage effectiveness, is the dominant metric, a flawed metric, but still the dominant metric of energy efficiency within data centers today. And it's essentially all of the energy that the data center consumes divided by the energy that is doing the useful work, so the power that's actually going to the servers, right? So you've got servers plus all the overhead divided by power for just the servers, right? And of course, within the overhead, a very large component is typically the mechanical cooling systems, right, to keep the facility within the desired temperature range. So I spent all this time, just like downloading manually these reams of data, because Google, being Google, is a very data-driven company. And even back, in 2013 at this time, right, we were collecting loads of data. So I just manually download this data into like Python and R and MATLAB and just plot it, right, to see if I could find hidden correlations within the data. It's like a scavenger hunt, which is actually kind of fun. But then one day I thought to myself, well, what if we use machine learning to do what I'm doing manually anyway and analyze this enormous volume of data, right? Maybe there's hidden treasures to be found within this data. Right. And keep in mind, this is in 2013, so no one was really talking about machine learning outside of a few academic circles, right? Right. But I had just taken a class called Introduction to Machine Learning, taught by a guy named Professor Andrew Ng. It was an online course at Stanford. And, it was an academic interest for me, right? A curiosity. So I applied it to my day job, and it was one of those rare cases where, like, it's so eye-opening, because what I discovered is that actually there's a lot of hidden correlations and insights within this data that I never knew about before. I never knew the correlation between PUE and supply air temperature. I didn't know the correlation between PUE and like a cooling tower downcomer set point, for example, right? But there were all these crazy insights that were emerging from the data. So this is what actually kicked off the fascination for me, right? And then in 2016, something called AlphaGo happened. So this tiny company called DeepMind, rocked the AI world, right? And it kind of leaked into the public consciousness, especially in some of the Asian societies, right, where DeepMind released an agent called AlphaGo that beat the world's grandmaster Lee Sedol from Korea. And Lee Sedol has been the champion, at Go for like the past decade, right? He is a Go grandmaster, just like there are chess grandmasters, right? He's the Magnus Carlsen of Go for the past decade. And, Go has long been considered a pinnacle of human intelligence, both within Asian societies and a grand challenge within the AI community. And here comes this AI agent, right, that beats the reigning world champion at what is supposed to be the pinnacle of human intelligence, right? And I was one of hundreds of millions of people watching this around the world, and I thought to myself, holy moly, this is crazy, right? And
everybody else said, we're dead. You said this is crazy. It's over.
Right? But for me, it was so fascinating that we had trained an agent right? That we created an agent that taught itself to become best at Go, right? We didn't go in and hard code the rules for how this agent should play like what we did with Deep Blue, right? Deep Blue is a rules and heuristics driven sort of approach where the computer beat the world grandmaster at the time, Garry Kasparov, through a lot of lovingly handcrafted.
This is in chess.
This is in chess, right? But here we have an AI agent that actually taught itself to become the best. So I reached out to a person named Mustafa Soliman, who is a co-founder of DeepMind at the time, and now he works at Microsoft. And as a side note, he'd become my future boss, but I had no idea at the time, right? I just sent him a random cold email called data centers plus reinforcement learning equals awesome ? And I described this idea, this theory, that if we can train these AI agents to become the best in the world at very complex games like Go, then surely they can learn other types of complex games that I'm very familiar with, like let's minimize the energy consumption of Google's data centers, right? So much to my surprise, Moose actually replied and said, this sounds like a great idea. And 2 weeks later, we were sitting down in Mountain View campus where Google's headquarters are, and we sketched out the idea of what it would be like to actually use a variation of AlphaGo to directly control a very large Google data center, right? And when we turned on the AI agent, at this large, 90 megawatt data center, right? On day one, the AI showed 12% energy savings, which was, honestly incredible for two reasons. One, the scale of these data centers, right? They're big data centers, right? But two, they're supposed to be highly optimized already because people, Google hires people like me to sit around all day and write math equations and do hydraulic modeling and stuff, right, to design the most efficient data centers. But this AI is finding ways to be more optimal, right, in these very data centers that we designed in the first place, that we thought we knew how they're supposed to operate. And then more importantly, we let it run for 1 year. And exactly 1 year later, that same AI was showing 30% energy savings without us doing anything, right? We didn't go in and write new math equations or write new sequences of operations or whatever for how we think this data center is supposed to operate. This is purely the AI given a game to play and the AI learning to become better at it, right? And then teaching itself to just fundamentally improve itself over time. So for me, that was really the aha moment when this AI system that we had built taught me, who is supposed to be the expert in data center energy efficiency and mechanical cooling systems, ways to operate that mechanical cooling system that I had no idea about. And I was like, this has to be the future, right? Like these AI technologies are fundamentally, they augment our capabilities. They are engines of knowledge discovery and creation. They can turn raw data into knowledge that we didn't know about before.
Yeah. So we're going to dive into that, but I can't help think that some version of young Jim didn't say, dadgummit, no more scavenger hunts. The AI, I had so much fun doing these scavenger hunts, which only an engineer would do. How's your day going? I am on a scavenger hunt for efficiency here in this data center. I would be thinking about, man, can I get my colleagues to the paintball course and shoot them? Like that would be fun for me. Actually, it wouldn't be fun. I'm so big that I'm an easy target. It's not funny, but it's. Are you from the Bay Area originally, or where are you?
Yes. Okay. So was actually raised in a smaller city called Edmonton, Alberta, in Canada.
Oh, okay.
Which, funnily enough, is actually like the birthplace of reinforcement learning. I tell people all the time that I was at the epicenter of reinforcement learning when nobody knew what the heck was going on in this tiny, dusty research lab there. My mom was actually a postgrad student at the University of Alberta at the time.
Okay.
I was a tiny kid. I was hanging out in her chemistry lab doing who knows what, right?
Right.
But I tell people I was there. Then I moved to the Bay Area, right? Grew up there and joined Google afterwards. Okay.
Did you go to school in the Bay Area?
Yes, I did.
So you have this experience. You email your future boss, and you get involved in this, and then from there now you have your own organization. What's the name of your company? Phaedra. And is it focused on the same idea that you're teasing out for us right now?
Yes. So my company, Phaedra, has a broader mission than what we did previously at Google, right?
Okay.
The experience at Google and DeepMind taught us that these self-learning AI systems can be incredibly powerful, right? But I'm a mechanical engineer by training, right? And what I see is a world of static physical infrastructure that slowly degrades over time. We hear all these stories all the time, right, about like factories in the Midwest that are slowly degrading or falling into disarray, right? But I see a very different future where by leveraging these intelligent self-learning technologies, these factories and these data centers can actually teach themselves to get better over time, right? I see a world of automatically increasing prosperity by intelligently leveraging all the data that is coming off of these systems. So fundamentally, what we do is we create self-learning automation systems, right, for physical infrastructure, starting first and foremost with data centers.
So, gosh, there's so much there. I almost wish I could apply that to myself, just as a human being, because just like you're describing a Midwest data center falling into disarray and disrepair. As a middle-aged guy, I find myself falling into disarray and disrepair. I know not to eat the guac, but I cannot stop.
But it's tempting.
It's so tempting. Lord, get it behind me. But so as you think about this now in your current role, but also with your experience at Google DeepMind, and you're in conversations all the time, not just with data center people, although you and I know each other through the data center conversations. How do you see practically this idea that you're proposing to organizations or to the industry, and like industries, big critical infrastructure like a data center might be, which is getting a lot of attention now. The White House is, the current administration, when this publishes, it will be a new administration.
Yep.
But both of those administrations, Department of Energy, they're all talking about data centers. They're all talking about artificial intelligence. This is a super important focus for the United States and the world for that matter, but the United States is what we're talking about. How do you see it fundamentally transforming both the design of a data center and the operations? You've talked about the potential, but as you're thinking about this now, or in your experience, you're seeing it. How do you think I suppose that is it, the potential on what this could look like?
Yeah, absolutely. It's a good question. So I think the single biggest misconception about AI today, not just as it applies to data centers, the world that we live in, or physical infrastructure, but just in general, right, is this conflation of AI with automation, right? People tend to think that AI, is predominantly used to automate routine tasks, right? And in doing so, displace people of labor, right? And don't get me wrong, there absolutely is, a large element of that, right? AI can indeed be trained. If the underlying training data exists, AI can be trained to perform these routine tasks, right? But I think that grossly misunderstands what the real potential and where the real impact of AI is going to come from, right? Everything in my experience has said that AI is fundamentally a tool for creativity, right? It helps us develop knowledge and innovation where it did not exist before, right? It is a tool of automatic knowledge acquisition and discovery. And I think the most impactful areas of AI we're just starting to see, right? If you look at not just AlphaGo but AlphaFold, which DeepMind recently just actually got a Nobel Prize for, right, within the last 2 or 3 months. Protein folding has been one of the biggest single challenges, right, in the world of biology for decades, right? And protein folding is so fundamental, right, to human health and prosperity, right? But there are hundreds of trillions, ways that these proteins can fold, right? So for the longest time, our ability to discover new drugs that improve human health and fight cancer or whatever, right, has been limited computationally by this immense complexity. And yet, if you look at what AlphaFold did, right, AlphaFold is actually grossly accelerating drug discovery by orders of magnitude. We used to take years or tens of years for R&D, right, is now taking a fraction of the time, right? This is where you're going to see the biggest improvements, right? If you look at AlphaGo, for example, right, from a very simplistic, naive lens, you could say like, oh, well, this AI system displaced the Go grandmasters. What more is there for humans to do if the AI is a reigning, world champion now? But Lee Sedol has such a different, and I would argue, beautiful view on it, right? If you look at the Netflix documentary and the interviews that followed, Lee Sedol said that when he was playing AlphaGo, the AI system, he quote unquote saw the hand of God when he was playing this AI. And for the first time in 10 years, so because he's been at the top for 10 years, right, there's no one to challenge him. So his ELO rating, which is like this measure of like how well you play games, right? His ELO rating had plateaued because he was at the top of his game. And then for the first time in 10 years, something came along that challenged him, that was better than him. And you know what happened? His ELO rating climbed for the first time in 10 years afterwards, right? And then for me personally, in like my much, much smaller, piece of the world, right? Like for me, this is so personal because I helped design those mechanical cooling systems in Google's data centers in the first place, right? Like I did the CFD modeling, I wrote the math equations, I wrote the sequence of operations, right, for how that facility should operate. In theory, I'm supposed to be the subject matter expert for data center cooling, right? And this very AI system that we designed taught me things about that system I designed in the first place that I didn't know about. Right? So all of which is to say, I think the biggest impact of AI is actually knowledge acquisition and discovery. It's not automation, but people do tend to conflate the two.
How do you think then with that, by the way, before I ask this, I gotta, this is certain, it's just a personal philosophical question for you.
Yeah.
So when you're a grandmaster like that and you see the hand of God or you see this, I am sure, or I would suspect, it's kind of like being a competitor, an athlete, and you think you've won the Iowa State Fair. I don't know, I always pick on Iowa, but whatever. Like you're the fastest person in a 3-state area, and then you go to the national championships in
it's a totally
New York,
different ball game,
and you might be number 18. You might be number 1. No disrespect to the Midwest, but you get the best in the entire country, and for some people, when they see that, they realize, wow, here's great competition, and I need to change my diet and my training and these other things. But for other people, they realize, I'm the greatest basketball player in my state, but I'm losing 8 inches to this player from Missouri or from California or whatever. Like I can't overcome that. Do you know what I mean? Yeah. And so there's this philosophical concept of, and we've seen it with prisoners of war, we see it in religious texts, we see it all kinds of places. If I don't think I can win, I lose hope. You know what I mean? Like I can never, there's no amount of, I'm not going to be fast enough. It's kind of like when I was a kid playing a rogue in World of Warcraft, and I thought I was really cool and tricky, but I was in my 30s, and actually I was in my 40s. And then the real rogues from the PvP, the Horde, clan, like I was naked and dead before I even knew they were in the area. And I realized I should just go farm. I probably got the wrong character. People listening to this will have no idea what I'm talking about. But my point just is that the risk for something is, and I don't know if this applies to, AI within data centers, but just if a tool comes in and I'm not inspired because it can outpick me, it can outthink me, it can whatever. I'm brokenhearted, I'm defeated, as opposed to this grandmaster. I wonder if at some point, because the machine's gonna, they're gonna keep learning. The human experience is like our eyes are exponentially more complicated. The protein folds within us, our DNA code, are so complicated. There's not any computer for any or any software in the near future that can compete with it, which isn't the same as the ability to process or whatever. So I don't want to take our conversation sideways, but my reaction is as you talk about some circumstances where a human being is competing or participating in an area, to your point, you got inspired because the tool can do better scavenger hunting than you.
Yes.
But if your heart's desire was to do the scavenger hunt and you now realize you don't think of it differently, I now have a tool to help me scavenger hunt exponentially better or different and be thrilled by that. But the exercise of doing scavenger hunts has now been taken from me.
Yeah.
Like that feels like that could be defeating. I don't know.
Yeah, I mean, it is a very different philosophical approach to this. And I mean, we're seeing this play out live in all aspects of society, right? I mean, I think for me, the exciting part is really just harnessing the technology to achieve the things that we care about, right? Like, for me, I care a lot about the energy efficiency of these data centers, right? So this is a very narrow application of an immensely powerful technology that can do so much more. You could use it for water optimization or improving the reliability and thermal stability of data centers, and you can do a lot more outside of data centers too, right? But I fundamentally see it as a tool that can help us better achieve the things that we care about. But to your point, yes, the activities, our relationship of who's actually performing those activities is going to change, right? Like when cars came out and displaced horse and buggies, right? Like, that was a massive change. It completely changed the relationship and the industries involved within them, right? But I would argue, and I think most people would, that we ultimately came out better for it, right? But I mean, this is the beauty of human technological progress, right? Like every time new technologies comes out that fundamentally unlocks entire new skill sets, right? We adapt, we change, right? Our relationship with the technology, but humans have always been best at harnessing technology to achieve the things that we care about.
Yeah. I don't disagree. We'll spend the whole time in this section, so let's just keep going. So would you imagine with that potential it impacting the design of data centers? It's got to be at the forefront of thinking before or even as somebody is building the brick and mortar.
Yeah.
Like we need this tool to be interwoven. Artificial intelligence augmentation to be interwoven within. For a wide variety of reasons.
Yeah.
How do you see it impacting?
Yeah, it's a great question. I think the biggest impact will actually arrive in the form of we will be abstracting ourselves to a higher level of design, right, and supervision. So what I mean by that is, in our industry today, and obviously we focus a lot on the data center industry since that's what we know and love, right? So I'll use it as a working example, but this will apply, across the board, right? Within the data center industry, we hire experts, right? Like you and me and other, people in this facility, right? To use their domain knowledge to lovingly craft rules and heuristics for how we think a facility should operate, right? Or how we think a facility should be designed. So I'm literally talking about, what we in the industry would typically call a sequence of operations, right? Where, we say, if the weather is this and the load is that, right, then do X, right? And this results in a very long document of like 200 pages or whatever, right? That then results in even more ladder logic. So like programming where someone goes into the PLCs and the BMS or the SCADA system, right, and implements millions of lines of code, right? That's going to radically change, right? Where in the future, I believe that we will instead provide the rules for these very intelligent AI agents, right, to learn from and the game that we want them to play optimally. So instead of us writing how we think the game should be played, what's going to happen is we're going to behave more like managers and supervisors, right?
Just tell them the objective.
Exactly, right? In the reinforcement learning world, right, that I come from, we call them, objective functions and actions and constraints, right? Which we often simplify down to the game. What is the game that you want it to play? What is the sandbox that it has to stay within, right? Is your objective function power usage effectiveness? Is your objective function water? Is your objective function thermal stability and reliability? Is your objective function, maximizing the amount of useful compute you can get out of your data center, right? Actions. What are the knobs and levers that you're willing to allow the AI to control and manipulate in pursuit of those objective functions? and constraints? What are the hard, guardrails and the do not touch red lines, right? That, and the soft lines, right? That you want the AI to respect, that it can't go out of, right? But as long as we can define these games for these AI agents and we can map those games into measurable outcomes, right? So like the actual data streams, right? That represent the ground truth of how well the AI is playing that game, then the AI can teach itself, right? The nuances of the game and become the best in the world at playing that particular game. It can become the Lee Sedol, right, of playing that game. So that's the world that I see, right? And what that means is, it doesn't displace or replace the need for domain knowledge. It actually requires you to have more domain knowledge in order to abstract yourself one level higher, right? Like we've all had like shitty managers before, right, where they don't know what the hell they're talking about, right? And
I have never had one of those, Jim. I don't know what you're talking about.
But in this future world that I see, I think in order to give the right direction, you fundamentally have to understand the underlying foundation yourself first, right? So I don't think it displaces the need for domain knowledge. I think it actually increases the importance of understanding what it is that the nuances of the system that you want the AI to control, so that you can give it effective direction, right? So again, it's the relationship that I see is more like a supervisor, where in the future we'll have these AI agents that do things on our behalf, but someone knowledgeable has to tell them exactly what to do and what not to do.
So I love that idea of supervisor. How do you, and the objective. So at some point, once upon a time, at least, for example, with kids, I had to teach them how to make their peanut butter and jelly sandwich or whatever. And it was a catastrophe. It wasn't just like, I thought it was simple. I show them how to do it, leave the room. I mean, it might even had like, okay, now you do it in front of me.
Yep.
But the first time I just left them to themselves, I don't know how you can spread peanut butter from the pantry to the sink across the floor and the cat get it on the side of their head. The jelly, I don't think jelly hit the bread, but they ate like half the thing. Like it was just the dishes, you can just imagine, spread everywhere, the mess. You're like, what is going on? Yeah. Whereas later in life, you could just say, it was a different kind of messes, but I didn't even have to tell them. Like if you're hungry, go fix yourself something to eat.
Yep.
And you know where to get the stuff that you need, whether it's the fridge or the pantry or whatever.
It's a higher level of abstraction, right? You used to make the peanut butter jelly sandwiches yourself, but now you can say like, hey, if you're hungry, make yourself a sandwich.
That's right. And clean up behind you and do these things. And oh, by the way, if we're running low on resources, let me know. So as you imagine future data centers and we're rolling artificial intelligence into them in the way that you're describing it, not just automation, although it can be used to remove the little screws from the back of the hard drive. If we don't want a human to stand there and do that, I'd rather the human go do something else and have a tool or a machine do that. But how do you imagine sort of this supervisor relationship? Is the software going to come back and tell the people, I've accomplished my task, here's improvements I've discovered, here's anomalies uncovered, here's whatever. Here's my, in other words, like a person, right? It's the junior tech, or maybe not even a junior tech, a senior tech coming back to their supervisor and basically give them a report. All good.
Yep.
Here's some things that I've noticed that you might want to pay attention to, or even from the floor, hey, I'm out here by fan 7, and it's, even though the boilerplate says this, the reading says this, I'm hearing some harmonic dissonance. You want me to do something about it? How do you imagine this relationship?
It's an evolving relationship that involves a very, very large amount of trust building, right? Because, I mean, to state the obvious, like, humans don't naturally trust black box systems, right? By nature being black box, right? So, and we should totally dive into this later. We can turn these black boxes more into white boxes, right? But fundamentally, it is a long trust building exercise, right? And the analogy that I often think of here is the relationship that a manager supervisor that you might have with an intern, right? When you hire a fresh out of college grad or intern or whatever, right? You give them some narrow set of responsibilities, right? And the intern knocks it out of the park, and you say, "Wow, that was great. Now you get some more expanded opportunities." The intern does that really well. Okay, well now you're a full-time employee. You get an ever expanding set of responsibilities as you demonstrate yourself being capable of achieving them, right? That's the same relationship that that we have with these AI systems. And this isn't even a hypothetical. Like literally at my company, Phaedra, we see this happening every single day, right? With the folks we work with, where initially we come in and our partners will say, okay, well, here's what your AI is allowed to do, right? And we do that for a few months, and they say, wow, that was pretty good. You actually did this really well, and it works better than our current way of doing things, right? Okay, well, what else can we ask the AI to do? Should we ask it to control some air handlers? Should we ask it to control, and these are real examples, can your AI control the cogen facility on site that happens to make power, right? That and steam that goes to support other mission critical systems, right? But the point being that people don't naturally trust these systems, rightfully so, right? If you've never experienced it. So you have to start small, build the foundation of trust, right? Do things like turning black box systems into white box systems. And then fundamentally, just like our human relationships today, right? You start giving it more responsibilities, but only after it's proven itself.
Yeah. I agree. I'm wondering how we get there. And let me tell you what I mean. Not like, I'm sure as an engineer, programmatically, you can think about that, right? Yeah. In my earlier analogy about making lunch,
the PB&Js.
The PB&Js or whatever, right? Yeah. They started getting into my canned chicken and making chicken salad, which irritated the dog mess out of me. I'll tell you that right now. But the reason why it wasn't just that they understood the process and procedures, but the reasons why they really began to adhere to it was there was a consequence if they didn't.
Yes.
Their first goal was to eat, right? Whatever that looked like. I get something in my belly. That's for their own personal satiation. So what was the motivation for them to do it in an organized way, to clean up their mess or whatever, was the consequences from their dad if they didn't. And there were real consequences. And one of the reasons why I began trusting them with those smaller things, later with more dangerous things, up to including cars, which might have been an overreach on my part. I'll just tell you that. They're all in their
PB&J to cars.
Yeah, all in their 20s. I want to go back to some Welch's jam. But anyway, there's real consequence.
Yeah.
You, I presume, flew down here on a commercial airline.
Yeah.
When you can afford your own airplane, let me know, because I'd like to go for. But a commercial airliner, and I'll bet you on that airplane, whether it's AI or some other combination of technology, if those pilots wanted to, they would have to do nothing to get that plane from the gate.
Yep.
Maybe they have to get it out onto the taxiway or whatever. Yep. But there's little physical interaction they need to do to get it from Seattle to Atlanta.
Yes.
It could do everything.
It's already like
with no
99%
humans. So
automated.
Why do we want, and why aren't we accepting of an empty cockpit? Because the consequence to the passengers, at least in our imagination, this may be completely incorrect way to think about it, but it's how we think about it. If I have people up there, even if they are statistically shown to be less reliable, accurate, intuitive. I got to interview Dr. Daniel Kahneman before he passed on the podcast, won Nobel Prize for writing a book called Thinking Fast and Slow.
Love that book.
Yeah, about human intuition that's not professional intuition, right? So my point just there is that we want pilots in those cockpits because there's something in our reptile brain that says those human beings want to live just like I want to live. They want to perform, so they get their raises, their Go score goes up. They are recognized by their peers. They want to be alive and go home to their family. And even if for one of them, all of those things are not true, for the other one or the other four that are in the cockpit, it is true. Yep. Even though the technology could do it all, the technology, if it makes a mistake, if the humans make a mistake, their life is over. Their career could be over. Their life could be over. Their reputation could be over. Whatever. There's a lot at stake for them.
You're saying you're tying this to the consequence of the
for sure. Yeah. So why I have trust to whatever degree that I have trust is there's a lot in it for them and for multiple of them. Whereas the machine, if it fails, it's like meh.
Yeah.
You know, it's like me getting crushed in World of Warcraft or StarCraft or whatever. Meh, reboot. You know, I used to race online a lot when I was younger, kind of my journey into computers, story for another day. And if you wreck at 220 miles an hour on the turn 4 of California, you're irritated. For some of these sports people, it could be hundreds of thousands. For the team, it could be millions of dollars to fail in Dota or whatever. But your life is not on the line, right? Whereas if I'm just trusting the machine, I'm not particularly worried about reputation or promotion. I want that machine to be all in, getting to Atlanta in a safe way. And so when you talk about, obviously, we're not necessarily talking about life and death in a data center. That's not the same dramatic, melodramatic example. But I'm curious, as a programmer, when people are saying, look, this data center, it has to do three things. At least this is my assertion. It has to always be on. If it's not always on, it's not a data center. Or something else, but it's not a data center. It has to be safe, affordable, reliable, on power. That's number one. Number two, or 1B, it has to be always available. It has to be connected, right? So I am always on, and I have a path to the electrons that are moving around in it, and the molecules that are cooling the electrons, and whatever's happening in there, it's available so that I can interact with that. If I'm not available, even if I have power, I'm something else, but I'm not a data center. I'm some other, I'm a compute hub. I'm a AI training hub. I'm a whatever. But if I'm not sending and receiving information from it, I'm not a data center. And then the third thing is I have to be always secure. Whether it's physically secure, logically secure, I have to be secure on who can access this stuff. So those are the three things. So if I'm a operator, so an organization like mine, we either design or participate in the design, we either build or participate in the build, we almost exclusively operate them, we maintain them, we have yet to have to recycle them. But that's our deal. We design, build, operate, and maintain data centers. And so when an organization, you guys have talked about this many times in panels, off stage, privately, at dinner or whatever. But this interesting conversation when we're going to talk to, or you're going to talk to organizations like ours about, I want to augment your folks, and I want your folks to trust these systems with the livelihood of always on, always available, always secure. We're talking about AI in the broad, not Phaedra specific. How, that's the, I don't want to get into adaptation. We're going to talk about that more in a minute. But how do you imagine that going to where if my engineer or that team fails, there's meaningful consequence to them. And so they are highly motivated beyond, doggone it, I missed a metric.
Yes, it's their careers on the line.
Everything, reputation, the safety of their crew members, depending upon who they are, right? So that's I know that's several minutes of but how do you think about that, and how do you discuss that trust area?
Yeah. I mean, it's an incredibly important and nuanced and big topic, to state the obvious, right? Mm-hmm. The first thing I think of is actually one of the things that folks outside of the AI community, and in particular the reinforcement learning community, don't realize is that a large part of what...
Don't scare us, Jim. Do not. We want to know the wizard is out there. If you pull back the curtain and I see some middle-aged guy named Fred that I'm trusting my whole world to, not
Fred
Oz,
is the black box.
I'm going to be very disappointed.
I think, there's a concept of,
Scoot up to the mic a little.
there's a concept of AI researchers, like busily typing to their keyboards or writing some whiz bang algorithms, right? Which, don't get me wrong, of course, does happen to an extent, right? But a large part of what our AI researchers and engineers are actually doing is crafting the game right. You have to define. Remember when I said earlier, how do you build trust in these systems? How do you, how do you make sure that the AI actually does the right thing? Well, you got to give it the right instructions, right? We've all been in situations where we gave someone the wrong instructions or loosely interpreted or vague instructions, and then the wrong thing happened, right? These AI systems operate exactly the same way. So one of the most important aspects of building trust, right, with our partners, with plant operators and facility technicians is actually who is giving the AI the instructions? It's you. It's not me, right? You know the
not
most
with that
about
attitude, that's for sure.
But what we often tell our partners, right, rightfully so, is like, you know the most about your facility. You're the one who's actually spent 5, 10, sometimes even 20 years in some of these large facilities you work in, right? You know everything about the facility. When you walk the floor, just by the sound, right, the ball bearings, you know that something is wrong, right? We need to capture that knowledge and digitize it, right? So step number 1 of the trust building exercise is actually making it super clear who is giving the AI the direction. It's you. You're the one defining the game. The AI is your agent. It's your AI. It's your minion, right? It will do exactly what it is that you want it to do, but doggone it, we need to define the game really well, right? So large part of what Phaedra's AI engineers and AI researchers in general are doing, right, is what we would call, and this is going to get into a bit of industry jargon, we craft the reward function. Okay. Right? The objective function is what most people outside the industry would call it, right? Someone has to tell the AI what good looks like and what it's allowed to do and what it's not allowed to do. Now that sounds incredibly simple when we say it like that, right? But it's actually a really nuanced task. So I'll give you a very simple example over here, right? When I was starting my AI journey and I was just starting to experiment with this technology back in 2013, and everyone, even within Google, thought I was crazy for experimenting with AI technologies, right, for data centers. One of the very first lessons that I learned was actually the importance of crafting the objective function, right? Because I didn't put the proper constraints on the system. All I told the AI was, you need to minimize the PUE of this big-ass data center, right? That's all I said. And the very first thing that the AI did was, okay, was come back and say, well, we need to shut off all the cooling. Right. If we shut off all the cooling, then the PUE is going to plummet.
That reminds me of somebody said, telling the AI, get rid of cancer. Great, let's get rid of all these carbon life forms. Wait a minute.
And and there's a million variations of this, right? So there is a professor of philosophy. I think his name is Nick Bostrom, who has this concept of an AI whose job is to maximize like paper clips, right? And the AI, because it's a poorly crafted objective function, the AI destroys the world in its pursuit of making paper clips, right? But the point over here is we need to define the game correctly, and who actually gets to define the game. It has to be the plant operators, the facility managers, the people who actually know the most about their facility, right? That is step number 1. And our relationship is making sure that that game is played well, right? That there is data behind how to play this game, and that the AI is learning the right things, right, about playing that game.
Like, how do we maintain our skills? What's that relationship like, do you imagine? How do you help solve that where you're not training in academia? In other words, I can train people on reading a map, but unless you drive across the country a number of times and it's just you really don't develop the skill. So how do you imagine that intersection?
Yeah, it's a super interesting question.
Take your time, no pressure.
By the way, I know exactly what you're talking about in the sense that, it's been years since I was the one, helping to design and operate these data centers, right? So you absolutely do lose some of your technical grounding, right? The higher level of abstraction that you operate.
You can see the strategic probably better. Yeah. Like when I was a kid in the Army and I was an infantry guy, airborne, and then mech. And every day you're out running mission practice. I never had to go to combat, thank goodness. But you're practicing, usually not with live ammo, but sometimes with live ammo, which really gets your attention when bullets are whizzing by you or whatever, right? And so you are on it. You're not just physically able to do it. Now I might be able to get to the cafeteria like 2 doors down, but that I'd still be out of breath. But back then, like you could do the whole thing.
Totally.
But I didn't necessarily understand the strategic value if in the middle of this mission we can't get to that objective or whatever. Do I just bypass it? Like I find out that I've got fewer bullets or fewer people or the circumstances have changed. I might not have because I don't have enough experience to know, we'll just bypass it or retreat or whatever. Like we train on that a lot, but the more time you spend away from the tactic, usually the better you get at the strategy, but the less capable you are at executing the tactic. Like they may know, I need to suppress this, but I don't have the skill to shoot anymore. Like, if they're within a 50-meter whatever, I could do it. But if I got to hit a quarter, 150, 200 feet away, I don't have that muscle memory. So how do you, that's the balance I would say. If we're using technology to augment, I want the extra, but I don't want to lose the potential. So how do we think about that?
No, I mean, it is a super fascinating and gnarly question. And that balance is going to change from person to person and organization to organization, right? Like what comfortable of abstraction are you comfortable, right, operating at? Well, let me first state the obvious, right? Going back to your original example of how now we have these GPS systems that guide us everywhere, right? I think all of us would argue that is a good thing. We prefer living in this world where we don't have to navigate by the sun or have to memorize, every street, name or whatever, right? So, but the tricky part is actually, balancing that with losing touch on the tactical side, right? I don't have a good answer for this, right? Other than, yes, we will always need some degree of training such that when these technologies, right, hopefully very rarely, but if these technologies ever do fail us, we do need to be able to step in, right? We can't completely lose track of the tactical side, right? And, for me, that looks, this gets back to what we were talking about earlier, right? In order to define the game, in order to tell the AI what you want it to do properly, you have to fundamentally understand the system. You have to deeply understand, what the minimum and maximum differential pressure is or the minimum pump speed below which you get cavitation effects, right? Like you got to have that level of knowledge if you're going to tell the AI what to do. So at this point, I don't see that as being a huge danger because you actually need fundamentally so much domain knowledge to tell the AI what to do in the first place. But that is also because the sort of AI that we're talking about today is in the infancy stages, right? Now, there will come a point when the AI is good at doing tactics and strategy. I have no doubt that's coming. Now, granted, it's going to be a while before we get there, probably a decade or whatever, right? So we'll have time to adapt. And I don't have a good solution for when it's a grading, I guess is what I'm trying to say, right? Like right now, on this grading of tactics to strategy, like general level strategy, right? You've got like the AI is like over here. But as the technology progresses and becomes more powerful, the stuff that the AI is capable of doing will slowly grow over time, as is the course of humans' relationship with technology, right? And we will continuously need to take on higher and higher level things.
I think in my intuition tells me that a organization that's working through this is sort of where I started with before, is the pilots, commercial pilots. That machine, it's not just the technology on that's constantly looking for obstacles in the air and changing weather patterns, whatever. But it's many of the designs, especially the very large planes, almost fly-by-wire. Like they need these tools to operate all the hydraulics and whatever efficiently. If you lose that, they're really trained to get it to the ground safely, and that's about it. But they have to spend a certain amount of time in a simulator. So they go regularly through simulation and simulation and simulation. So there's a certain amount of minimum requirement to become a commercial airline pilot for one of the major airlines, whether it's military, private pilot, small carrier, whatever, where the tools are less sophisticated. They don't want to do away with these tools. These are augmenting human beings, and many times taking away the tasks that would make them fatigued.
I love this analogy because that perfectly encapsulates our relationship with the technology, right? And why the technology makes our lives better and why we move to adopt the technology in the first place, right? Like, to your point, planes are 99% automated today, right? Like, the pilots in the cockpit, they're not actively, pushing buttons and, and maneuvering 99% of the time except during takeoff and landing, right?
Yeah.
And that's because we have realized that the technology is better at keeping the passengers safe, right? Like, we have ceded that control, right, to automation systems because it is better for everyone, right? But to your point, well, why do these pilots exist in the first place, right? Well, they still need to be capable of stepping in when things do go wrong, right?
I need their intuition.
Yeah,
right?
and they'll probably do a more suboptimal job of flying, right, where it may not be as, or in the data center world, right, it may not be as efficient as an AI technology, right, but you still need the backstop.
Right.
Yeah.
It will be curious to see how this adoption,
Yeah.
certainly there are people that are in my age group, which is the predominant management level of data centers, that is going to be replaced pretty quickly, certainly in the next 5 years, by not people 5 or 8 years younger, but 15 to 20 years younger, that are coming out of that use these tools in the military, for example.
Yeah.
Maybe not AI specifically, but they're used to using small modular reactors. They're used to, like, they don't. Yeah. We're not trying to aim a weapon at an incoming anti-ship missile. We're using tools to do that. We're using tools to predict anomalies that the submarines hear in the ocean or whatever, along with human collaboration to make what we turn. No, that's a whale. No, that's this. That's some redneck on his pontoon boat. That's nothing. It's not an enemy. That's what it feels like we're moving towards.
Yeah, 100%. And I mean, like, it's AI is, of course, like the topic of the moment, right? But this, even you and I have talked through so many examples of ways in which technology has just made whatever happens we're doing better, right? And AI is simply one of, many dozens of different technologies, right, that have come. But I would argue the thing that makes AI different now, the thing that makes AI scary, stripping away the media part, when people think Terminator, Skynet, or whatever, right, the emotional aspect, the thing that actually makes AI different is that it's non-deterministic.
What does that mean?
It's not, it's a black box system.
Okay.
Right? And it's more, based upon statistics as it is based upon, cold, hard physics, right? And that, that black box nature of the technology, that is the net new thing that makes people uncomfortable, right? We can't explain well why the AI is doing certain things that it does, which is why I was saying earlier, like, one of the things that we invest a lot of time at Phaedra and other people do within the AI industry as well, right, is turning these black box systems into white box systems, right? So, to use a more personal example, one of the things that we've discovered is important for our partners is explaining why does the AI do certain things, right? Why did it turn on that chiller? What would have happened if the AI didn't turn on the chiller? What would the PUE impact have been, right? What would the energy impact have been, right? But, like, being able to articulate those things, and initially humans, right, are, the plan operators are interested in double checking the AI's math, right? But at some point you build enough trust in your AI agent or in the person reporting to you that you're not constantly micromanaging them. You're not double checking, like, did you actually do that thing right? You just inherently trust them. But in the early infancy stages of technology adoption that we are in today, right, people do like having, more white box systems, right, so that they can double check what the AI is doing to verify that it makes factual mathematical sense.
Yeah. Let me ask you this. One of the things that is really AI is impacting, because we're building and operating data centers to handle AI workloads.
Yeah.
And it's causing this thing called oscillation. So data centers, typically, we love steady eddy, right? The river just flowing at a certain, you can rise a little in the spring when the snow melts, and you can decrease a little bit at the end of summer when it's, droughtish. But most of the time, we don't want the water to approach the bank.
Yeah.
And in some workloads, not all, but some workloads, we call them training workloads, but there are other examples. Either a portion of the infrastructure within the data center, or maybe even in some cases, the entire workload in a data center has this oscillating, peaky whatever. And electricity hates that. Our base load hates that. The grid hates that. Even if you're doing it for yourself, a lot of people are talking about on-site generation now. It hates that. That's just not how this stuff has worked over time. How could you imagine tools that you're familiar with, whether they're tools that you make or tools that you're familiar with, can help us? Because sometimes we expect these things are going to happen faster than people can deal. There's this back to illusion of control. We imagine we can change the environment of a data center. We don't do it in real time. We do it within operational parameters that may take hours, if not days, to adjust or whatever. How would you imagine us dealing with this really real challenge of oscillating and peaky loads?
Yeah, it's a really good question. And I mean, there's, this isn't even a hypothetical. Like, it is literally here today, right?
Right.
I remember, Meta a few months ago released a very beautiful, detailed. Very few people call white paper beautiful, but
we've come
I
to
thought
that
it was
understanding
beautiful.
too. Of course, you had us at scavenger hunt about an hour ago.
But they released this very detailed, fascinating case study about what it took to train their next generation Llama open source foundation models, right? And like literally it was training like a 50 megawatt cluster of like H100s, right? And 200.
H100s are GPU chips.
GPU chips, right? So, and there was a specific section that diverged away from like the AI portion, right, into like what actually had to happen from a data center operations perspective to support training these next generation models, right? And they talked about how like the load would swing, over 10 megawatts a minute, right? Which is insane. Like in the world that we come from, like a 10 megawatt swing in 1 minute is just bonkers.
Yeah.
Right. And, I think a lot of folks don't yet. So when I take a step back, right, I see some clouds on the horizon that are also opportunities, right? If we embrace technologies, right, to adapt with them. And some of the major challenges, right, that we're just starting to face is that data centers are becoming a hell of a lot bigger, a hell of a lot more complex, and a hell of a lot more dynamic.
Yeah.
Right. And that is going to make us feel super, super uncomfortable. Because to your point, when I joined the industry in 2010, like we could count on these Intel Xeon CPUs year after year consuming 100 to 120 watts per chip if we're really pushing it, right? But now you see this exponential increase where NVIDIA is releasing new architectures once per year now. And every time they do that, it climbs by hundreds of watts, right?
And people are saying, what's curious, because there were all these declarations before when we moved to blade servers, then we moved to virtual machines or whatever, that it was going to, exponentially increase the power consumption. Yeah. It didn't, because the apps to consume it and the organizations to consume it weren't as sophisticated as the hardware. They'd run at 20 or 30% load. A few of the big hyperscalers might run at 75 or 80%. The difference now is those GPUs are primarily targeted, and by that we just mean, for our audience that lives under a rock and doesn't know any of this stuff, is like these big gaming cards, if you're a gamer, right? But they have these things that these chips that consume a lot of power, but the people that are buying them, these top 10, top 15 companies, or companies that are building a service that you can consume from them, they plan on running those suckers at 95 to 100% efficiency. Like it's like your light bulb. It's either on or it's off. There's no sort of, it's kind of dimming and what. Nope, it's on or off.
Yep. So, to your point, right, big challenges. And what we've already talked about, data centers are becoming a hell of a lot bigger, a hell of a lot more complex, right? More knobs and levers to operate, and a hell of a lot more dynamic, right? It's really going to make us uncomfortable, right? Now, in terms of solutions to this, right now, obviously I'm going to have a more biased perspective in the sense that I do think this is where AI technologies will shine, right? AI shines in applications of complexity that is underpinned by data, right? So absolutely, I believe with all of my heart that this is where AI can really help us. But I also have a different, perspective on, another dual path where I think the industry has to go, right? I think that it is inevitable that the future of the data center industry will be full stack vertical integration.
What does that mean?
What I mean is traditionally, when we think about a data center, right, as an engineering nerd, I break down the data center into three control planes, three independently operating systems, big independent systems. You have what we traditionally think of within the data center world that you and I come from, which is the facility level controls, right? So this is where you have your electrical and your mechanical people, your technicians, whomever, right, operating the physical infrastructure, the shell of the building, right? And from a control perspective, we would typically refer to this as like the BMS or the SCADA level controls, right, and maybe some PLCs. Then you get to the interior of the data center where the servers and the racks and the liquid cooling lies, right? And that is its own independent control plane, right? Typically, the liquid cooling where the racks are operating separately, right? There's no coordination between the facility level controls and what's going on at the rack level, right?
That's right.
And then you get down to the software level, right? The software scheduling level, the GPU workload scheduling level, right? This is where you've got hundreds of thousands of software jobs being scheduled every minute, right? And they can have extraordinarily large impact. And that operates completely independently. What the software engineers are doing are totally different from what, the facility manager, is doing, right? So the point I'm trying to make is that we have a very complex system with three major systems that are operating totally independently and blindly to each other. That's got to change, especially in a world where when a software engineer kicks off a big-ass training job and it causes a 10 megawatt swing per minute at the facility level, shouldn't that facility person know what the hell is going on at the software level, right? So my point is, I believe very strongly that the future of the data center industry has to be full stack vertical integration where you have incredibly intelligent, i.e. AI-driven control systems that can handle massive amounts of complexity, orders of magnitude more complexity, because it knows what is happening at the software scheduling level and is operating the facility in advance to absorb that shock. If you knew that a model job, a training job, or a training run was about to kick off, right? Or if you knew a 20 megawatt spike was coming, surely you would start subcooling your thermal system to absorb that shock, right? As opposed to reacting after the fact. Surely you would take proactive measures, right? Alternatively, if you knew that it's cold outside and your mechanical plant has, is running at like 30% of its rated cooling output, right? Then surely you would actually want to get the most out of your very expensive GPUs that you paid hundreds of millions of dollars for, right? And actually put more workloads on them, right? Ramp them up harder, faster to get the most out of your investment, which means that we actually oversubscribe the data center, right? We can actually start running the cooling systems harder because we know that there's so much extra capacity because it's cold outside, right? Like there's so many interesting things that you can do that aren't being done today. We are just scratching the surface of what compute infrastructure actually looks like. And that infrastructure is not going to be completely independent control planes. It's going to be the entire data center as a single stack, right? And NVIDIA and Jensen in particular, right? What I'm saying is not new, right? I'm simply re-articulating a vision that other people much smarter than me have already realized, right? But Jensen in particular refers to this idea as data centers being the new unit of compute, right? The compute is not the GPU. It is the GPU to the liquid cooling to the facility. It is an entire system.
Right. So we've done that in IT for a long time where you've got compute, network, and storage, and they have to be, the back planes have to be able to, you can do all the jobs you want in the compute, but if you don't have the ability to distribute it through the network, in band or out of band, it fails. If your storage can't, both long-term storage and real-time storage can't handle it, you fail. And if those two are fast, like all three legs of the stool have to be, the compute has to keep up with network has to keep up with storage, and they have to communicate. Here's our challenge. I don't disagree with what you're saying. This is where I'm maybe not pessimistic, but skeptical on its adoption. Makes complete sense. I don't disagree. We've talked about this in IT since the 80s. I mean, other than the mainframe where it sort of did it, but since then, both in IT and even in data centers for the longest time. It would work. It absolutely has an opportunity to be spectacularly impactful if you own your own data center and it's only your workloads in there. You can oversubscribe it. Like it's your, if Microsoft or Google or Amazon or whoever, it's your business. But if you're a multi-tenant, if you're an operator and you take a data hall or racks or whatever, and your performance could impact and I've asked this to many, I've heard this from many engineers from a stage or some other private conversation from many of these organizations. I'm like, that's absolutely. Are you going to allow us to integrate? Because there's a level of transparency you have to give us. Let's presume you have the ability to do it. Because they don't all. But let's just presume, fill in the blank company, that you can integrate our physical infrastructure with your software layer or whatever in the way that it can do scheduling and do these other things. And AI is smart enough that it doesn't impact any of the other tenants. Let's just presume that exists. Would you do that? No, is the answer right now. They just won't for whatever reason, whatever risk reason, whatever... I don't know. They won't.
Not yet.
Not yet. Fair enough. But not yet. But see, this promise has been out there for 40 years, not just in data centers, but just period, because we come out of the managed service provider and IT stack. Look, if you would give us more information, whether I'm patching your infrastructure, whether I'm doing scheduled maintenance on infrastructure around you, and if I knew you were doing a SQL migration or whatever, man, we could do so much more coordination. No. Not tied into the system.
The constraints aren't strong enough yet. They're not feeling the pain enough yet.
Fair enough. Right? But I'm sorry, go ahead.
Yeah. So when the power constraints are so tight that there's no more power left to source, right? When the land is taken up, when the labor pools are taken up, right, and there's just no more data center capacity, right, to build, then we have to look at harder but potentially more impactful solutions, right? Like increasing the utilization of these data centers that we already have. We have a massive there's 33 gigawatts of data center capacity in the U.S. today. That's going to go up to 100 gigawatts according to city groups, right? Projections by, I think they said like 2028 or something, right? It's a massive amount of capacity. But when there's no more capacity left, right, then you have to use or new capacity left to build, then you have to use your existing assets better, right? You have to adopt technologies like that.
Yeah, I don't disagree. It will be interesting to see. It's a forcing function. Dean Nelson, our good friend Dean Nelson over at Cato and iMasons, talks about this all the time, but I've challenged him. I was like, when you were a leader at Sun or Uber or anywhere else you were, young Dean Nelson, cocky 30, 40-year-old Dean Nelson, and somebody came up to you, an operator, a provider like me would come up and say, hey, you need to do this because it's better for the environment or it's whatever. Absolutely not. I want my reserve pool, in my UPS to be this, no oversubscription of whatever. Dean, we can show you through 40 years of data and statistical defense of the reliability. A tier 2 data center with a high preventative maintenance program is more reliable than a tier 3 data center with a marginal. So long as these programs are at this whatever, you can have single points of failure and you don't need this reservation. 0% chance that was going to go. Not picking on Dean because that is his policy today. And Dean would say you do not need your stranding capacity right now in a variety of data center markets. If you stop doing 3 to make 2 and just did 3 to make 3 in your UPS or whatever you did, you didn't have this reserve of ride through, you'd be fine. And by the way, resiliency now comes at the application across multiple data centers, not an availability zone. Not entirely, I don't entirely agree with him. But anyway, that's sort of, I'm sure he's going to send me a note saying, that's not my exact position. But I believe that to be true. My point is that even when we go back to organizations and say, fully integrated stack, whatever, let's work together, they do not, unless that whole building that I'm doing is dedicated to a customer, they're just not interested in doing it. Yeah. But here's where I think it might be getting forced. Once upon a time, back in 2005, 2008, I can't even tell you how many RFPs or RFQs or whatever came to us and said, hey, we want to see an efficiency of this, your PUE. We were talking about PUE at the beginning. It needs to look like this. Now, most of us are brownfield buildings that had no idea what you meant by PUE. Yeah. A PUE of a 3, which those in our industry know that's not a great PUE. My shoes have a PUE of 3, right? Oh. And so they wanted to see a PUE of much less than that, maybe even half. Now, at Greenfield, it better at least be half on a path to get as close to 1 as you can. But anyway, I just say that to say, until Christian at Microsoft, Joe at Google, and others said, we need to start putting into these RFPs, you must have we want to see what your solution is on power utilization effectiveness, right? And in the beginning, it was loose. People measure differently. It's still a little bit like that, or at different times, or not a hard standard. But when they began putting it in and said, you will not do business with us unless you have that in there, we can understand it, you have governance around it or whatever. All of a sudden, the whole world started talking about it. All of a sudden, everybody started putting blanking panels and capturing it, on and on and on. So the big hyperscalers, because they're the customers out there, not just for themselves, but imposing upon the operators like us, said, you're not doing business with us unless this is in place. So when that happens, I absolutely can see this. But until then, the engineers at those places, of whom you used to be one, they said, look, in our engineering model, we need a certain amount of resiliency. And what would happen is that would get compounded across engineering groups. And so we'd over-engineer stuff. So I would like to see, I love the potential, and we will for sure be there at some point in the future, to your point about scarcity of whatever the scarceness is.
At some point it will happen. The pain isn't high enough yet, right, to take on that endeavor. But I completely understand and agree, with the point. I mean, it has to be the hyperscalers, driving this first and foremost, right? And I think right now, honestly, it is easier to build more data centers and more capacity than it is to make your existing assets more efficient.
Yeah.
But that will change at some point because of the fundamental scarcity of resources.
For sure. We're seeing that power, fiber, whatever. Once upon a time in any big metropolitan area, to deal with traffic congestion, they would just build another loop around. Yeah. Well, now their people are all there. So the right way to do that is so disruptive and so expensive, and the regulation around it, the people available to build the road or to lay the fiber in the ground or to get those, even if the whole world approved, you can come through my backyard with a high power line or whatever, to go from county to county and state to state is a lot of regulation and just the resources of the people available to make that happen. And so how do we get better? I completely agree. Yeah. We've got just a few minutes left because I've got to free you up so you can get up the road to your lunch, and I got some stuff coming up here. But per usual, we got to about half of my questions that I wrote down. But I guess sort of sum it up in the last 5 minutes, what do you think, maybe a two-part question, what are the barriers to adoption in the way that you're thinking about it in general, if any, are, and how will those be overcome? And what do you think besides the whole stack integration, what do you think, what are some watermarks we're going to see, you would imagine we're going to see in the next 3 to 5 years of this is what the future adoption of this looks like? Yeah. So barriers to adoption, and what do you think the watermark, the big tells will be over the next few years of we're making progress or we're slowing down?
Yeah, it's a great question. I see two primary barriers to adoption, right? one of which we've covered, which is the cultural aspects, right? The trust building aspect, right? There are some industries, like we already said, notably with self-driving cars, but even with the airline industry, right, that are well on their way into adopting these sort of technologies that have already ceded control, right, of manual control of an airplane, for example, right? But for us in the data center industry, we're more at the beginning of that, right? So there absolutely is a cultural element, and of course, as we stated earlier, the way, right, to build trust, right, is to start small, make sure that it's actually the plant operators and engineers who are telling their AI what their AI is supposed to be doing, right?
By the way, I cannot wait for the day to see one of my plant operators walking down the hall talking into his Kindle where he's got Jarvis living, arguing with him. I'm telling you, no. That passionate two-way conversation will be absolutely hilarious. It's like sometimes I get Siri to argue with Alexa and just see what happens. Anyway, keep going. I'm sorry to interrupt.
Yeah. And then, of course, the turning the black box systems into the white box systems to build that trust over time, right? We've touched on that. From a technical perspective, right, so in a non-cultural perspective, AI is only as good as the data, right, that is being trained upon. So one of the things that we've consistently noticed is that, I mean, if you look across the industry, right, I mean, there are folks all over the spectrum on how quote-unquote AI ready they actually are, right? Everyone sees the shiny AI applications, but what they don't realize is, AI is kind of like an iceberg where you see the shiny application at the top, but you don't realize the data infrastructure that rests underneath it, right? Most of our partners have never deeply looked at their data before, right? They're not looking at 10,000, sensor trends per minute, right?
Right.
They don't realize that a lot of their sensors, have gone stuck or have gone missing like years ago, right? They don't realize that not only is data quality important, but data access is important. How are you getting that data? Is it low latency data? Do you have like a global DSIM or a cloud-based DCIM where we have a programmatic way to access high volumes of data, right?
Or where it's hallucinating. We found in our own data lakes duplication of data.
Yes.
So it's trying to solve for something like, whoa, that number is way too big because it's multiple sources that don't know it or totally. Multiple paths are looking at the same requirement, but they're under an they think they're the only one looking at it.
You've got duplicated data. You've got data that lives in different silos, right? And also a big part of it is what the hell does the data even mean, right? Like these naming conventions are so arbitrary at times, right? That when our solutions engineers and our AI people look at the data, it's not at all obvious that, hey, this is a temperature sensor corresponding to rack X in data hall Y.
That's right.
There's no way you can tell that, right? So a large part of what we actually do is collecting the data, aggregating it, normalizing it, cleaning it, making it nice and accessible, formatting it in the right way so it's understandable, not just for the AI, but even to ourselves and to our partners, right? And then we can do fancy things like train the AI on the data, right? But I guess what I'm trying to say is, everyone's at different stages in their AI journey, but the AI is fundamentally only as good as the data foundation. So step number one is always make sure that you have a really good data foundation to work off of, right? And to expand that a little bit, it's even beyond the data, it's also a controls foundation, right? Because we're a closed loop control system. So for us in particular, we also do a lot of like audits and forensics on the existing control system to make sure that there's a solid foundation built off of that. The things you think you're controlling are actually controllable, right, by the AI, for example.
Right.
Now, I think we're at the very early stages of this, right, where you're starting to see companies like Phaedra and others, right, come out and start, talking about using AI within the data center industry, not just hosting AI workloads, but using AI ourselves, right? I think energy and PUE optimization is one of many, many things we could be doing with this technology, right? I think that in the future, to your question about adoption, I think we'll see AI to drive more intelligent water optimization, right? Because in a lot of cases, especially if you have, different types of like mechanical cooling or adiabatic cooling or whatever, right? You can actually trade off between how much energy you burn versus how much water you're consuming, right? So I think we'll see more intelligent water optimization coming, which will impact water scarce regions like Phoenix or Texas, right, where a lot of data center capacity is being built now. I think that we'll see AI for disaster mitigation and recovery itself, where currently when things go wrong, right, that's when human operators take over. But actually, one of our partners recently pointed out to us, like, actually, that's when I want the AI to be in the control seat the most. I want that because it's able to handle a lot more data and have that global view of what's happening. That's when I actually want the AI to be in the control seat, in the driver's seat, to make the right decisions to stabilize my plant, right?
Yeah.
I think that we'll see AI to figure out what are the true limits of how much we can push things, how much can we actually safely oversubscribe the data center if tenants are willing to do so, right? And or AI to make decisions around like how much redundancy and online capacity is actually needed. Like there's a whole host of things, but fundamentally, you can't make good AI systems unless you define the game that you want it to play well, and you can map that game to solid underlying data.
Jim, thanks for coming on the show today. I really appreciate it. We talked about a lot.
We did. Thank you, David. It generally was a fascinating conversation. I really enjoyed it.
My great pleasure. Hey, if you liked that conversation, click the like button. If you loved it, hit subscribe. We'll talk to you next time, everybody. We'll see you.